Hello, shiny, happy people holding hands. Today is lesson 4. Now, today we're going to look at the product rule. Remember what we've been doing for these last little while, these last few lessons, is we've been looking at ways to solve the derivative without having to do first principles, without having to go back to limits and do that whole slog of limits. So today we're going to look at what happens when we have two functions that are being multiplied by each other. Is there a way to take the derivative of that without actually first multiplying all the two functions together? And of course there is. Now, my warning to you, just remember, there's beauty in the mess. So I'm about to walk you through a proof. And actually, once you understand what I've done, the proof is actually not complicated. But it looks complicated. It's a schwack of letters. And if you kind of zone out for a minute and then suddenly look at the slide, you'll be like, what the heck just happened? Go through it a couple times if you need to, okay? It's not complicated once you see what I'm doing. Essentially, I just want to derive for you the product rule, okay? And how we're going to do that is we're going to take a look at the following. We are going to actually approach this like a proof. So the question that we're asking ourselves is, if f of x is x and g of x is x squared, does f of x times g of x, does the derivative of f of x times g of x equal the derivative of f of x times the derivative of g of x? Now, essentially saying, again, don't get scared. Essentially, we're saying, or we're posing the question, does the derivative of a product equal the derivative of each one multiplied together? Can we just kind of distribute the derivative, for lack of a better word, okay? Now, here's how we're going to go about doing that then. This is a very simple proof. Now, you guys are going to yell at me and say, this does not look simple in a minute, but it is, okay? Just stay with me. There's a very simple proof to do here to prove or disprove this conjecture. Now, I'm not saying this is true, okay? I'm saying we're going to try and figure out if it's true. So we're going to determine the derivative of f of x times g of x using first principles, okay? So if we were to do that, we're looking at something like this. The derivative would be the limit as h approaches 0 of, now it's f of x g of x that we're trying to find the derivative of. So I'm going to use f of x plus h g of x plus h minus f of x g of x, right? So just stop and ponder what I did there for a sec, okay? Now, I'm going to get things just a little bit more complicated. And what we're going to do is we're going to add in a plus or minus f of x plus h times g of x. Now, you may be like, why are we doing that? And I'm going to be like, well, you'll see. But mathematically, I need you to understand that I'm not changing anything, okay? Right? Think back to 20-1 and completing the square. When we wanted to find that magic number, we added 16 and subtracted 16, right? And as long as we add and subtract the same thing, we're not altering the math at all. Okay, so if I add in an f of x plus h g of x and I subtract an f of x plus h g of x at the same time, then we're not altering anything, and that's okay. So I'm going to do that, and I even color coded it with the same blue. So all I've done, this is the same thing that was on the previous slide, except I added in a subtraction of f of x plus h g of x with an addition of f of x plus h g of x. Okay, so this whole thing here, oh, I'm probably in the way. Let me take that away. Let me take myself away. So this whole thing here is 0, right? So I haven't changed the question at all, algebraically, okay? Now, the next thing I want to do is I want to split things right here, okay? So what I'm going to do is I'm going to split this into two separate limits, okay? If I split it into two separate limits, and I'm allowed to do that, that was one of the limit properties that we dealt with way back when we went through limits. Okay, so that would end up looking like this. I just took essentially the first half and split it into one limit, and I'm adding the second half as a separate limit. Okay, all allowable moves to make. I'm going to bring myself back so you can see me smiling at you, and you know it's all going to be okay. So all I've done there is I've split it into two limits that are being added together. Now, I'm going to take a look at this first limit, and I'm going to say, hey, is there anything I can factor out of there? Well, yeah, both of them have this f of x plus h. So I can factor an f of x plus h out of that guy. And on the second guy, both of them have a g of x. So I can factor the g of x out of those guys. Okay, if I do that, I end up looking like this. Okay, so I factored the f of x plus h out, and that left me with the g of x plus h minus g of x, sorry. And then on the other guy, I factored the g of x out, and that left me with f of x plus h minus f of x. Now, I get that at this point in our conversation, some of you guys are kind of shaking with fear, okay? Because of the amount of functions that are happening here, the amount of just everything that's going on. Stop, go back, listen to this video again, okay? I'm only doing little bits and pieces to this in order to get to where I need to go. Okay, overall, I'm not doing anything that's like super convoluted. It just looks convoluted. Okay, so the very first thing I did was I wanted to take the limit. So I set up my limit formula. I threw in a plus and minus, an addition and subtraction of that f of x plus h g of x. Then I split the big guy into two separate limits that were being added together. Within those two separate limits, I looked for a greatest common factor and I factored it out. And that's where I am now. Okay, so now I'm going to split one more time. Because this is multiplication here, I can split and have two separate limits being multiplied by each other. Okay, so we can split the limits up again into multiplication. So what would that look like? Well, that would look like this. Okay, so I end up with the limit of f of x plus h, where h approaches 0, times the limit of g of x plus h minus g of x over h, where h approaches 0. Now that was just that first half split into two separate limits that were being multiplied by each other. Okay, then I did the same thing on the second guy. So I end up with the limit of g of x as h approaches 0 times the limit of f of x plus h minus f of x over h, where h approaches 0. Again, I just took that back half. I had two factors that were being multiplied together anyway, so I separated them out into two limits where each separate limit is being multiplied by each other. Okay? All right. Now, why would I do that? Well, because now I'm looking at h approaches 0. Well, if h approaches 0, this just becomes f of x, right? This is the derivative of g of x. This is g of x. And this is the derivative of f of x. So, y'all still with me? So we've got the derivative of f of x times g of x will equal f of x times the derivative of g of x plus g of x times the derivative of f of x. Now, first of all, we have to go back to answer the question we actually were asking. The actual question we were asking a long time ago is, does the derivative of f of x times g of x equal the derivative of f of x times the derivative of g of x? And the answer now is no, it does not. It equals this, okay? This would be a handy proof for you to understand and to know, okay? All right, just let me get rid of my ink there. Okay, and so we have arrived at the product rule. The product rule says the derivative of f of x times g of x equals f of x times the derivative of g of x plus g of x times the derivative of f of x. Or another way to say that is the derivative of f of x times g of x plus f of x times the derivative of g of x. They mean the same thing, right? All I've done is reverse the order here and put that in front. Personally, I like to do it that second way because in my own notation, I'm just going to go fg derivative will equal fg plus fg, and then I put a derivative there and there, right? It's the derivative of f times g plus f times the derivative of g, okay? Okay, so that's the product rule. That's what we're going to be practicing like right now. So find the derivative of the following. Okay, again, if you want to do the derivative, you're going to do the derivative of f times g plus f times the derivative of g. So we'll call this first guy here f. We'll call this second guy g. Well, the derivative of f, okay, you did this in the last lesson. That's going to be 2x minus 3, right? Times g, which is x to the 5 minus 6, plus f, x squared minus 3x minus 2, times the derivative of g, which would be 5x to the 4. Okay, so you should be looking at something like this. Now, I will also tell you this, this method of writing the product rule is what's on your formula sheet as well. So again, it doesn't matter to me which way you do it, but this is the one on your formula sheet. To me, this is just the one that makes the most sense. But you do whatever you want. Okay, so now I need to clean this up. So I'm going to get rid of all the brackets. So 2x times x to the 5, 2x times -6, neg3 times x to the 5, neg3 times neg6. Then this 5x4 would have to get distributed to everything. So you may want to pause and do that yourself. You end up with, whoops, this guy here. Okay, and then when I combine like terms, what, I got a 2x to the 6 and a 5x to the 6, so that'll give me a 7x to the 6, minus 18x to the 5, minus 10x to the 4, minus 12x plus 6. Okay. Now, just to try and make connections, you could have taken this, you could have done all the multiplication, right? And then you could have taken the derivative of every term like we were doing yesterday, okay? But if you see a product like this, we would want you to show that you know how to use the product rule, okay? All of this is being able to show off all the toolboxes or all the tools that you have in your toolbox, okay? So when you see product, think product rule. Okay, let's do another one. Let's try this one. So again, we're going to call f the root of x, and we're going to call g 5 minus root of x. So if I'm going to go with the derivative of f, well, root of x is the same as x to the 1/2, right? So the derivative of x to the 1/2 would be 1/2 x to the negative 1/2, just using the power rule there, times 5 minus root x. Then plus f, which is the root of x. I'm going to probably change that to x to the 1/2 right away as well. I'm going to change everything to exponents until I've got this in a more simplified manner. And then the derivative of g, well, g is 5 minus the root of x. So that's 5 minus x to the 1/2. If that x to the 1/2, if that 1/2 comes to the front, that'll be negative 1/2 x to the negative 1/2. And the 5 drops off. Okay, so that is the derivative of f times g plus f times the derivative of g. Okay, now I want you to see here, essentially, you've got two terms right now, this term and this term. And I see a 1/2 x to the negative 1/2. That's a common factor to both of those. So right away, I'm just going to pull that out. I'm going to pull that to the front, hopefully make this look just a little nicer. So when I pull that 1/2 x to the negative 1/2 to the front, I'm left with 5 minus root x minus root x. Now, sorry, I hesitated there for a second, but this minus root x comes from this negative. I never pulled that negative out, so negative times root x, okay? Just in case you hesitated with me, that's where that came from, okay? I had this moment of, oh no, what have I done? But I'm right. Okay, so now let's take a look at this fella, okay? That essentially, the x to the negative 1/2, although it's nice to use the exponents when we're pulling things out or in or whatever, when we go to give a final answer, we would never answer with a negative exponent. So first of all, for sure, that x to the negative 1/2 is going to have to come down. I would write it as root x now as well, instead of x to the 1/2, okay? So the 2 is going to be on the bottom of a fraction from the 1/2, and then this is going to be root x on the bottom of a fraction, and then this here is going to be 5 minus 2 root x. So my final answer here would be 5 minus 2 root x all over 2 root x, and that would be as simple as we can make it. Okay? All right, so that's the product rule. Here is your job for the rest of this particular lesson, and then we will catch each other again for the quotient rule. So until then, have lots of fun. Take your time and make sure you're practicing lots. Check in with me if you have any questions. Okay, take care, guys.